Hi, and welcome to today's geometry lesson. We're looking at session 1.5 from your textbook today about angle pairs. And I want to just begin by saying that the information we get today, you're going to use it the whole rest of the trimester and beyond. So this is very important today. We're going to begin by defining a type of angle pair called complementary. Two angles are complementary, C-O-M-P-L-E-M-E-N-T-A-R-Y. Two angles are complementary if the sum of their measures is 90 degrees. Complementary angles are a pair of angles who, when you add their measures together, you get 90. So, angle A here has a measure of 40, angle B 50. That means that the measures of their angles together are 90 degrees, and that A and B are complementary. Notice that those two angles do not have to be sitting next to each other, although they could be. It's also possible that we could be looking at a right angle split up into two pieces. Those angles also are complementary since their measures must add to 90 degrees. Just some other language associated with. One of the complementary angles is said to be the complement of another. So if you see that in a book or on a quiz or test, it means that you're talking about one of the two angles in a complementary pair. One angle is the complement of the other. In this case, you could say that angle A is the complement of angle B. As far as numeric expressions goes, that's going to be important to us. The algebraic expression for the complement of angle A, well, if together the two of them add to 90, then the complement of angle A, which is angle B, must be the same thing as 90 minus the measure of angle A. Likewise, two angles are called supplementary if the measure or the sum of their measures, supplementary, means we add up to 180 degrees. The two angles pictured, ABC and CBD, are supplementary since when you add together 140 and 40, you get 180. Therefore, those angles are supplementary. So complementary means 90, supplementary means 180. And again, with the language, one of those angle pairs is the supplement of the other. And it would be appropriate to say that angle CBD is the supplement of angle CBA. The algebraic expression for a supplement, instead of 90 degrees, remember they added up to 180. So the supplement of one of those angles is 180 minus its measure. The next type of angle pair we're going to talk about are adjacent angles. And two angles are said to be adjacent. That's ADJ-ACENT. If they have a common vertex, that is, they have the same vertex and a common side. So they share a vertex and a side. Or another way of saying that is they are right next door to each other. Adjacent means next door. Angle ABC here, ABC is adjacent to angle CBE. If you think about that, they share the same vertex, B, and they share exactly one side. BC is in both of them, or ray BC is in both of them. They are adjacent because they sit one right next to the other. I'm sure that you have located another pair. I'm going to ask you to stop the video right now and write down another adjacent angle pair. I'll catch up with you in a minute. Okay, I hope that you also located angle ABD here is adjacent to angle DBE here, right next door to each other. Two adjacent angles form and folks, this is an important idea here. I'm going to put a star by this. They form a linear pair, it's called, if and only if they're non-common sides. Remember, if they're adjacent, they share a common side. This says their non-common sides have to be opposite rays. And if you look at that, GF is the opposite ray to GI. These guys form a linear pair. This little guy is telling you that phrase, if and only if, can be abbreviated this way. Linear pairs are important for many reasons, but the biggest one, which you can see right here, is if their outside edges form a line, then the sum of those angles must be 180 degrees. These guys must be supplementary because their outside edges form that line. Okay? 180 degrees all together in here. And that is going to be an important concept for us. The next type of angle pair we want to introduce you to are vertical angles. So two intersecting lines meet to form two pairs of vertical angles, they're called. Vertical angles. In the picture that we are looking at, angles 1 and 3 are vertical. And if you follow the book definition, that's because they are formed by this pair of intersecting lines. If that is the case, then you will also notice that angles 2 and 4 have to be vertical as well. This is the textbook definition. Vertical angles are formed by a pair of intersecting lines. One thing that I like to say, so this would be my own paraphrase of this, is that vertical angles are right across from each other. Okay? Right across from each other when two lines cross. And one thing that you may have guessed already just by looking at our picture, there's a special relationship between the measures of vertical angles. It's expressed in the vertical angle theorem, which says the measures of vertical angles are congruent. And a lot of times I'll abbreviate that by saying vertical angles are congruent. They must be. Angle 1 then has to have the same measure as angle 3. So not only are they vertical, but this is where you can go a step further. The measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4 in that picture. So if the measure of angle 1 is 42 degrees, boy, that's definitely not drawn to scale, but if that were 42 degrees, then so would angle 3. They have to be the same, 42 degrees. Since angles 1 and 2 form the linear pair, that is, they are adjacent and their edges form a line, their outside edges, you can also find the measure of angle 2 by subtracting from 180. They equal to 180. So if angle 1 is 42, then angle 2 must be 180 minus 42, which would be 138 if you do the subtraction. And since 2 and 4 have the same measure, 4 will also be 138 degrees. By knowing one angle in an intersection like this, you can talk about, or you can find measures for all 4, and that's pretty important. So far we've introduced 4 types of angle pairs. Those are complementary, supplementary, adjacent, and vertical. 4 angle pairs that we need to know about and that we'll use the rest of the year. This slide is copied from your textbook. It's very important information in geometry. Especially since we just looked at that picture where we told you that this was a 42-degree angle, even though it didn't look like it. See, we have to be able to tell in geometry what we can tell from a diagram and what's marked in a diagram. I want to have you look at this information with me. Some things you can assume to be true, okay? Some things you cannot. For example, it says, you can conclude, so these things are the yes things, okay? You can conclude that 2 angles are adjacent. If they look like they're next to each other, they are. You can conclude that angles are adjacent and supplementary. That is, if it looks like a linear pair, 2 angles that form a straight line, you can assume that that is true. You can tell when angles are vertical. Just from a diagram, if they are right across from each other when two lines cross, you can tell that they are vertical. Those three things are all about position. So it's okay for us in geometry to look at a diagram and assume that things are shown in their proper position. What is not okay is making the conclusion that things measure the same. Position is okay to assume, measurement is not. And I want to give you an example. These are things that you cannot assume. You can't assume that two angles are congruent or two segments are congruent unless, okay, there's only one exception, unless they are vertical angles or unless they're marked. If we want to say that two segments are congruent, we mark with a hash mark. The only way I can say that those are congruent is if I see that mark. The only way, unless again we have vertical angles, the only way to tell whether two angles are congruent is if they're marked. You can't just assume that those markings there. In fact, sometimes diagrams are meant to be confusing, right? We need to be able to tell whether measurements are really true, and the only way you can tell is by marking in the diagram. You cannot assume that an angle is a right angle just because it looks like it. So if we were to draw this picture and that's it, even though that looks like it might be a right angle, you don't know because it's not marked. You cannot assume that two angles are complementary from a picture. Again, if I drew in a ray here and said, okay, tell me about this angle and this one, since I don't know that there's a 90-degree there, I cannot tell that they are complementary. You can assume position. You cannot assume about the measure of things. And we want to put that to the test right here. I'm going to ask you to take a look at this diagram, and we want you to decide whether it's okay to make each of these conclusions based on what's shown above. I'm going to ask you to stop the video for a moment, and let's catch up afterwards. Let's see if we agree. Okay, welcome back. Now you can see how I've answered these questions, and I'd quickly like to go through them with you. Can we determine that TW segment is congruent to WV segment? And the answer to that is yes, because you can see the hash marks there. Since there's one mark on each, that means that they are congruent. The next one, PW and WQ, oh, it looks like they're congruent. No markings though, so it cannot be assumed, okay? That's not marked. Can we assume that angle TWQ is a right angle? No. Again, that's about measure. Right angle means 90 degrees, and we don't know that. It's not marked. And then lastly, and this is the trickiest one, segment TV bisects PQ. My answer to this is no, you cannot assume that. In the picture that's drawn, PQ definitely bisects TV, and we know that because we see those congruency markings here and here. It's TV that's bisected, not PQ. Good exercise, folks, in what can and cannot be assumed in a drawing. All right, that's it for us today. I'm going to have you get right out there to the website, please, and let's do the U-Try for section 1.5. See you in class tomorrow.